Thank you. Thank you. Thank you very much, and hello, everyone. Hello, everyone. Come on. Welcome. Thank you for joining in today. My name is Tanmay Bakshi, and my passion lies at the intersection of innovation and technology. Now, this intersection has an impact on billions of people's lives every single day worldwide, and that is epic. As a matter of fact, really, my goal here today at the City of Ideas is to give you all a brand new perspective on the world's most debated technology. And of course, that is artificial intelligence. But before I begin, I want to start off by saying a huge thank you to the entire team at the City of Ideas for putting together such a wonderful event and inviting me to be a part. I'm absolutely thrilled to be here. Huge round of applause for them. Come on. Now, they have not slept properly or eaten for weeks now, and so a huge appreciation to them for putting in this effort. And what I want to do today is I want to start off by giving you all a little tour of my journey into the world of technology. And like any good tour, we'll have to start off at the very beginning. And so I want to travel back in time by around 11 years, back to when I was 5 years old. Now, that's right, I got into the world of technology back when I was a curious 5-year-old. And as you can imagine, my curiosity really drove me from there. As a matter of fact, when I was 9, I had my very first iOS application, called T-Tables, accepted into the Apple App Store. This then led me to start my YouTube channel called Tanmay Teaches, which in turn led me to initiate my goal to reach out to and help at least 100,000 aspiring coders, to really help them innovate along their journey of learning to code. In fact, I'm really glad to say that so far I'm around 15,000 people there, and I'm always working towards this goal through numerous different media. Of course, there's my YouTube channel, but then there's the talks, the workshops, the keynotes that I have at schools, at universities, and conferences across the globe. Essentially, making it easy for people with ideas to implement technology where they believe it can make an impact. Thank you very much. Thank you. Thank you. Thank you. In fact, I'm also very glad to announce that to scale up this initiative, this year I had 3 of my books published: Hello Swift, Cognitive Computing with IBM Watson, and Tanmay Teaches Julia. Thank you again. Thank you. Thank you. Thank you. Now, I know I got a little ahead of myself, so how about we rewind a little bit? Now, you're probably wondering, well, how did I get into the world of next-generation technology in the first place? Well, you see, back when I was 11, of course, I was fascinated by technology, but I wasn't as interested in it as I was just a few years ago. And the reason was actually pretty simple. It's because I felt like technology, well, I didn't have that next big challenge to work on with technology. I didn't have that next big thing to do. But I'm glad to say that that all changed one day back when I was 11, when I stumbled upon a documentary on IBM Watson and how it not only played but won the Jeopardy game show against the 2 best human competitors on the game show, Ken Jennings and Brad Rutter. Now, when I stumbled upon this, I was immediately fascinated. I mean, 9 years ago, natural language understanding technology was completely unheard of, and today we take it for granted. You open up your phone, you can talk to Siri, Cortana, Google Now, Google Assistant, and still, 9 years ago, Watson was analyzing natural language more complex than today's systems can understand. And so when I stumbled upon this, I was immediately fascinated. And I wanted to know more about the world of machine learning technology. In fact, ever since then, I have been hooked to implementing machine learning in basically all of the different applications that I develop. And machine learning is a very pervasive technology in our lives. If you've opened up an app on your phone in the past few minutes, you've more than likely used machine learning in at least some capacity. And again, most likely without even realizing it. But because of this pervasiveness, machine learning can sometimes be a frightening or an intimidating technology. But I believe that when you boil it all down, machine learning at its very core is actually pretty simple. It's essentially just automating the way that we can extract actionable insights from entirely unstructured data. Now, I know that that's a lot to take in, so let me help you digest that a little bit. Now, why did we build computers as humans? We built them as tools to help us run mathematical operations at rates orders of magnitude faster and more precisely than we as humans ever could do in the past. And this has enabled us to do some amazing things. For example, we know that the moon was formed in a planetary collision 4 billion years ago because NASA could actually run those simulations on some of the world's largest supercomputers. That is an amazing ability of ours, that we've created technology that can do this. But then there's a problem. Because of this very goal nature of technology, it can only really do one thing: processing mathematical operations. It can't do anything else. For example, there are certain tasks that we find absolutely trivial as humans that computers simply cannot accomplish, fundamentally cannot. For example, right as I show you these two images, you instantly recognize the one on the left is a dog and the one on the right is a cat. And when you do so, it took you less than a nanosecond. Your visual cortex processed it, and you're on your way with life. But wait, computers can't do that. They can simulate planetary collisions, but they cannot analyze whether an image contains a dog or a cat. And the reason is simple. It's because of our human limitations and the computer's limitations. We cannot create mathematical functions that analyze every single pixel in an image to determine what they all mean in relation to each other. And therefore, we cannot have technology understand the unstructured data that we process and that we generate. Like, for example, when you take a look at these Google logos, you instantly recognize that they all represent the same brand, even if you had never seen a Google logo before. Of course, computers can't do that because we cannot create the mathematical rules that go behind doing something like this. And this is where machine learning technology comes to their rescue, to help us actually impart these abilities into the world of technology. But even though machine learning is so powerful, the terminology is a little unclear. For example, you probably haven't heard machine learning all that much. You've heard other terms like cognitive computing, or more than likely, artificial intelligence, AI. But I'm going to ask you to do me a favor. Let's forget about AI for just a second, and let's rewind back to machine learning, and I'll tell you why in just a second. Now, as I mentioned, machine learning is absolutely all around us. If you drive a Tesla car, you're using machine learning every single second. If you've got an Apple Watch Series 4 or 5, you are literally using machine learning every single second because it's looking at your sensor data, and if you take a hard fall, it'll report it to emergency services. As a matter of fact, I've worked on a wide variety of different projects in a wide variety of different fields that use the power of the machine learning algorithms that I've developed. For example, I'm working on a project in the field of dyslexia. Now, over 20% of people worldwide suffer from dyslexia. That's over 1 billion people. And what I'm working on doing is creating the world's first intuitive application that uses machine learning to adapt to the way a certain learner likes to learn, enabling them to have these machine learning-powered interventions that make the experience more fun. I'm also working on machine learning-powered applications that provide artificial communication to people who are unable to communicate naturally. And the way it works is by understanding EEG, electroencephalogram, your brain waves, the most complex biosignal in the human body, with the world's first neural network that can actually understand this raw data. As a matter of fact, I've reached the very first milestone, which is mental state recognition, being able to recognize what mental states a person is in. And I've also worked on a super fascinating project called Heart ID. The idea of Heart ID is to create a kind of biometric authentication that can do, for the world's first time, understanding your electrocardiogram, your ECG. It can identify you based off of the way your heart beats. Let's take a look at a quick example. Now, on screen, we've got Peter. What he's doing is he's holding an electrocardiogram sensor, and it's sending his data over to my application via Bluetooth. Now, I've already trained the application, and I've told it, this is Peter, you can trust him. And if I run a prediction, as you can see, prediction identified as Peter. But wait, What if someone who's not Peter tries to gain access? Remember, only Peter's heartbeat data is in my application so far. So if someone who's not Peter holds the sensor, feeds their data into the application, and they click on predict, it should say, as you can see, prediction not identified as Peter. Now, why would you want Heart ID over Face ID or Touch ID or iris recognition? Well, it's because I designed it with a particular goal in mind, to make it secure to the point that it can be used in a data center, but at the same time keep it so portable that you could put it in a smartwatch. Now, all of these different applications, whether it's a Tesla car driving itself, whether it is IBM Watson analyzing a contract, whether it's my Heart ID, whatever it is, it's all powered by the same deep learning core. Now, I know that sounds kind of surprising. I mean, how can all these technologies be powered by the same fundamental set of mathematical ideas? But it's true, and there's one specific implementation of these ideas that I want to talk about today. It's an implementation that I believe is most widely misunderstood, and these misunderstandings are detrimental to humanity because they are blinding us to the good future of machine learning. And we start to see negativity in the future, even though that negativity has no grounding in technological reality. And the field that I'm talking about is humanoid robots. Now, think about it like this. If you take a hard fall with your Apple Watch and it detects that fall, what's the technology called? Well, we call it machine learning. Now, imagine the exact same technology in a form factor like this one. What do we start calling it? We start calling it AI, artificial intelligence. Now, here's my question. Why did the terms change? Not when the software, but merely the hardware has changed. Well, I believe it's because we as humans, we've been able to scale up misinformation and deception to a level that has never been seen before in any technology or in any field. Now, think about it like this. AI is not really intelligent. But still, when I say modern artificial intelligence, the first thing that comes to your mind would be humanoid robots. And that's because the average person does not know enough about the technology to be able to determine that, hey, AI isn't really intelligent. And there are many people out there that are very willingly leveraging that fact in order to drive this idea further into our minds. As a matter of fact, before I continue, I want you to take a listen at something. And I'll tell you why I played it in just a moment. Now, what you just heard was a clip of music that I composed. But I'm not a musician, so how did I do it? Well, what I did is I trained a machine learning system on a bunch of piano sonatas from Mozart and Beethoven and asked it to generate more music. Now, I know what you're wondering, well, isn't that creativity in a machine? Well, no, quite the contrary, actually. This is not creative. This machine is never going to replace great artists like Beethoven and Mozart. Rather, the idea is that it took mathematical patterns from the data I fed in, and it restructured them in a way that seems novel, but actually isn't. And so modern artificial intelligence is not true human intelligence in a computer. It's not humanoid robots. Rather, it's just deep learning technology, modern machine learning, with a few more technologies sprinkled in to make it look intelligent. And deep learning at its very core is just function optimization. It's just mathematics. It's just calculus that's existed for over 400 years now. Sometimes I just like to call it fancy math, because that's all it is at the end of the day. It's not really intelligence. It's just a mathematical mapping of X and Y, two data sets. And so finally, what I'm trying to say is this. At the end of the day, even though we as humans think we're super special, we're actually not. We are primates at the end of the day. We are quite literally, by dictionary definition, primitive beings. And what that means is that it's super easy for us to deceive ourselves. I mean, think about it. Think about optical illusions. Your own subconscious mind is tricking your conscious mind into seeing something that isn't there. And I believe that AI is a very, very similar illusion. Except it's not optical, it's a mental illusion. And these mental illusions are super difficult to get rid of, because you can't just take out a ruler and measure something. You have to have an understanding of all the fields that go behind it, the technology, the psychology. and so much more. And so here's my hope. I hope that we can get off of this AI high. I hope we can sober down and deflate our expectations. And I even believe that in a perfect world, a world without friction, we wouldn't even call AI artificial intelligence. We would call AI augmented intelligence, because that's what it's all about. It's about augmenting our human capabilities with the power of the machines and the machine learning algorithms around us every single day. Thank you very much. Thank you.
Thank you for watching Deep World. Stay tuned for more explorations into ideas, arts, and sciences. Don't forget to like, share, and subscribe. But before you go, let's take a moment to explore the power of curiosity. Imagine a world where questioning the status quo is not just encouraged, but celebrated. Where every why leads to a new adventure, a new discovery, and a new way of thinking. This is the essence of Deep World. Curiosity is the engine that drives innovation, creativity, and understanding. It's what pushes us to look beyond the surface, to dig deeper, and to seek out the truths that lie beneath. It's the spark that ignites the fire of knowledge and the fuel that keeps it burning. So whether you're pondering the mysteries of the universe, the complexities of the human mind, or the beauty of artistic expression, remember that curiosity is your greatest ally. Keep asking questions, keep seeking answers, and never stop exploring. Join us on this journey of discovery, and let's unlock the endless possibilities that curiosity brings. Stay curious, stay inspired, and stay tuned to Deep World. Until next time, keep diving deep.